Welcome to the Cal Poly Compost facility here in San Luis Obispo. Today I would like to go over our composting operation. We, as you see behind me, run a windrow composting operation. Our feedstocks are manure based from all our animal confinement operations, and then we also take all the green waste from campus landscape services and incorporate that into our composting process. The site management for our operation is broken up into three areas. We have an area where we store raw feedstocks, and then the area behind me with windrows, those are active composting windrows. And then we have another site where we stockpile our finished compost for kind of final curing, and we keep it separate from the raw feedstocks and our active composting windrows. That's necessary so that we don't create any cross-contamination. We have strict SOPs, or strict operating procedures with regards to when we're handling raw feedstocks, that all that equipment is washed before we handle any of our ongoing compost windrows, or whether we're handling finished compost, because we don't want any cross-contamination, which can then lead to other issues when we're possibly spreading other contaminants. So we want to make sure we're keeping every step as clean as we can. Our annual production, we process about 7 to 8 million pounds of manure annually, and that is then turned into about 3,000 to 3,500 cubic yards of finished compost. Once we've reached a point where we have finished compost, we take several steps to ensure we have a stable product before sending it off for testing. And one of those methods we use is called a Solvita test. It's made by Woods End Lab, and what it does is it allows us to test what we consider a finished product for ammonia and CO2, or carbon dioxide levels. We run that test. It takes roughly 24 hours. We pull a sample, we let it sit overnight, and then we run it through the Solvita test, which takes about 4 to 5 hours. That gives us a, if you will, color-coded method for looking at ammonia and CO2. And if our levels indicate that we have a stable product, then that one test then reassures us that we can take a larger sample and send it off to a certified lab. The certified lab that we use is tied with the U.S. Composting Council's Seal of Testing Assurance, and that Seal of Testing Assurance program is a strict compost analysis that certain labs around the country are certified to do. So we'll send a sample of our latest batch off for that analysis. It comes back, and it goes through a myriad of properties, but in the end result, we have something that we can continue to evaluate our compost. It also reassures us that our composting process has dealt with weed seeds, salmonella, and E. coli, that we don't have any heavy metal issues, and that our nitrogen, phosphorus, potassium, other ingredients in the compost are all in a stable setting. The other thing that we belong to is the Organic Input Materials Program with the California Department of Food and Ag, so we're certified organic through that. So those two processes allow us a broader range of utilization. This can be used on our certified organic farm. It can be used on a conventional farm. So another area that compost producers have to consider in California is the regulatory environment. Here in California, we would be dealing with Cal Recycle, and we'd also be dealing with the Regional Water Quality Control Board. Both of them are regulatory agencies, and both of them have regulatory requirements for composting facilities. Those regulatory requirements are really based on the size of your composting operation. They're not going to pertain to your small backyard composter or small scale on-farm composting operation. Our particular composting operation does fall under kind of the minimum requirements that the regulatory agencies are looking at. Just to kind of give you a feel for scale, if you will, with our facility producing 3,500 cubic yards of finished compost, and we're handling 7 million pounds of compost, we're kind of on the low end of what they would deem a small regulated composting facility. Anything under that, especially if it's on farm or in your backyard, you really don't have any big concerns there. I think the main thing to be concerned about when you're setting up your composting operation is not to do it next to a wellhead, not to do it within a couple hundred feet of a live stream where you might have runoff issues, things like that. So just be cognizant of kind of where you're setting up your compost with regards to possible discharge or runoff during storm events that you can't really control. So now we want to talk about the characteristics of compost, and there's 10 key characteristics. I'm not going to go into length about each one, but I am going to talk about 4 critical characteristics that we take into account when we're blending our feedstocks and building a recipe for composting. And those 4 are, we look at the carbon to nitrogen ratio of each feedstock, we look at the percent moisture of each feedstock, we also measure the bulk density, and that's expressed in pounds per cubic yard. And then we also take into account the texture of that feedstock. So this is green waste, and our green waste is about 55% moisture, has a bulk density of 610 pounds per cubic yard. The CN ratio is 150. The percent carbon is 15, and the percent nitrogen is 0.1. The next feedstock is waste feed or silage from our dairy. The silage has 75% moisture, a bulk density of 1,300 pounds per cubic yard, a CN ratio of 12, percent carbon of 6, and percent nitrogen of 0.5. This next feedstock is our horse manure. It has approximately 45% moisture, a bulk density of 450 pounds per cubic yard, a CN ratio of 40, percent carbon is 22, and percent nitrogen is 0.6. The next feedstock is our separated solids from our dairy operation. This has 85% moisture, a bulk density of 1,400 pounds per cubic yard, a CN ratio of 18, percent carbon 6, and percent nitrogen 3. So now that we've looked at a number of feedstocks, you're looking at our finished compost. This has taken approximately 4 months to convert the feedstocks that you just looked at into a finished product. We have a nice black, rich product. There's no ammonia smell. It's more of an earthy smell. We feel it's one of our better products that we make here on campus. The one thing to consider when you look at these, I'm going to go back to one characteristic, and that's bulk density. We want to make sure that the bulk density range is somewhere between 800 to 1,000 pounds per cubic yard once we've blended our recipe. The other characteristic to remember is percent moisture needs to be in the range of 40 to 60%, with optimal range being 55% moisture. And we want that CN ratio to be in the neighborhood of 30 to 1. I'd like to cover some things about good composting practices that we want to make sure everybody understands, and it's kind of a little bit of a summary, but I think it's a good refresher now that we've talked about a number of different things. But those good practices, we want to understand our feedstocks really well, and that gets back to knowing each individual feedstock's characteristics when it comes to percent moisture, the CN ratio, the bulk density, and the texture, okay? And texture is a really good thing to incorporate, and normally you're going to get that with your carbon source, and different carbon sources that have anything from fine, which might be sawdust, all the way up to wood chips. And you want to try and find a happy medium in there, because if you have too many fines, you're going to end up with a kind of a light mix. You're going to have a hard time holding temperatures. If we get into too big of wood chips, we start to get into more of a density issue, and so if we can kind of find a happy medium, that compost pile is going to breathe, it's going to pull air in, and it's going to help facilitate that composting process. Another area that we want to talk about again is cross-contamination. We want to make sure that when you're handling raw feedstocks, that the equipment you're using to handle raw feedstocks are not then being used without proper cleaning when you're handling ongoing composting piles or finished compost. So when you're moving from kind of stage to stage, it's appropriate when you only have a few pieces of equipment that you maintain a level of sanitary conditions or cleanliness so that you can reduce any cross-contamination. Thirdly, we want to talk about pathogens in our composting process. The pathogen reduction phase is what we call in our windrowing process, or the PRP, is we have to, once we've initiated a windrow, in other words, we've laid out all the premix feedstocks, we've incorporated the green waste, and we've run our equipment and incorporated and turned this windrow, we've initiated the composting process. So then we're coming back in and we start tracking the internal temperatures of these windrows. These are temperature thermometers. This is a 3-footer so that it'll reach the center of the pile. And then we also use a shorter one so that we can kind of get an idea of what's happening on the exterior level of the compost pile as well for temperatures. During the PRP phase, once we've reached a temperature of 131 degrees minimum, we have to maintain that for 15 days straight. And during that 15 days, we have to turn that windrow a minimum of 5 times. That is what's classified as meeting the pathogen reduction phase, which then handles weed seeds, salmonella, and E. coli. And that's the first 15 days of our composting process. After that, then we don't have to maintain temperatures on a daily basis. We can do it every couple days, we can do it weekly, as long as we continue to track those temperatures throughout the composting process. But it doesn't have to be as intense once we've met that 15-day temperature regime. The other thing that's helpful with the thermometers is that if we have a differential temperature between the interior and what I'll call the exterior thermometer of at least 20 degrees, that's a good rule of thumb for us to use that would help us initiate turning that windrow. That means that we know the temperatures are hot enough that we can turn this windrow, and when we come back in 24 hours to do our next day's temperatures, we're going to be at 131 degrees or hotter. We do not want to try and exceed 150 to 160 degrees, because then we get into issues of disturbing the microbial activity going on, and what I'll call the good bugs versus the bad bugs. And we want to maintain a healthy environment for those good bugs to help us continue to compost the feedstocks that we have in this windrow. One other thing we do when we're checking temperatures in our compost windrows is while we're gathering the temperatures, it's always good to pull some of this compost back. And if you look closely, there's a fine layer of white mycelium growing here. And that is what we want to see, because we know we've got the right moisture conditions and that we've created a, if you will, a happy environment for those beneficial organisms to help us in the composting process. So some other characteristics to remember when you're in the composting process and you're going through that is you've got to have patience. For us, it takes anywhere from 3 to 4 to 5, 6 months to obtain a finished product, depending on the time of year. So it's not going to be something that happens overnight. So you've got to show some patience. The other thing is you've got to remember you got to keep an eye on your ammonia levels when you're composting. If you start to come into real high ammonia levels during the process, you probably want to look at potentially adding some more carbon, because that means you're developing an anaerobic situation, and that also will correspond to seeing some drops in temperature. It means the pile is not breathing, it's starting to kind of collapse on itself, and it needs to be aerated. The other thing we talked about was carbon dioxide levels. Again, when you're getting close to a finished product, and one method of doing that is using a Solvita test if you're interested, but it's not necessary. On our scale, we like it. If you're doing small scale, it's pretty much going to be up to you. Once you get to a point and you think you have a nice product that really doesn't smell of ammonia anymore, and it's got a nice dark texture to it, you're probably going to find that you've got a pretty good product and you're ready to use it. The other thing is we want to make sure we understand the hazards of using immature compost. And the one thing I want to point out is that if you're utilizing immature compost, and what I mean by immature compost is that the ammonia levels are way too high, you're still picking up a scent of ammonia, that means that potentially your carbon dioxide levels are still too high. And so if you take that product and you incorporate it into your soil, your vegetable beds, your planter box, whatever it is, that compost that's still immature is going to steal nutrients away from your plants, and potentially you're not going to see, or you're going to see an issue with your plants. In other words, those plants may react negatively to what you just put in the soil. You're not seeing any positive things happening with regards to your crop. So you want to be really sure that you're using a finished or a stable compost. I tell people a lot that are going out and they're buying it from somebody is to get a sample, or go see the operation, or go check it out, handle it, smell it, and make sure that what you're getting is a finished product. Sometimes in large compost operations, you can ask for their analysis information because they should be able to provide you per that batch. If they're doing, if they're in a testing program, they should be able to provide you that data and reassure you that what they're selling you is a finished product. There are a variety of composting methods. I'd like to talk briefly about small scale or backyard composting. I think some of the best information nowadays that you can get on composting and small scale composting is off the internet. There's a number of different methods being sold or manufactured. It's kind of whatever kind of fits. I think the biggest thing I can emphasize on backyard composting is, again, you really have to stay on top of it. It's not something you kind of throw together and leave. If you're happen to be building kind of a makeshift static pile at home, I recommend it be done on kind of a 4x4 by 4 area. You can even build a bin on top of an old pallet, or make a wire mesh container and fill that. But you want to make sure you're still looking at the feedstocks you're using so that your carbon to nitrogen ratio is okay, your moisture level's okay, and that you're turning that compost on a regular basis, and that you're monitoring the temperature. You can go to most nurseries now and find composting thermometers. You can get them off the internet. So small-scale composting operations on small farms, a real handy piece of equipment to have is a little front loader tractor that's got a front loader bucket on it. It doesn't have to be real big, especially if you're handling less than 500 cubic yards of compostable material a year. It makes for building your static piles real easy, because you can move the material around, you can turn the pile, and you can do it relatively quickly, and it doesn't take up a lot of your time. The other methods that I would have people investigate would be the aerated systems that they have now. There's aerated static piles, there's in-vessel systems, which are actually enclosed composting systems. So there's a number of methods out there for composting now. It's just a matter of kind of what fits best. Whether you're in your backyard, you're a small scale farmer who wants to do some composting, there's a number of methods out there to kind of look at and evaluate that best fit your